All right, so today is 1.3.2, adding, subtracting complex numbers. And this is very, very related to what we did last week, Monday and Tuesday. Remember we had the sides of the triangles. We just had to add together the two expressions, just like this. We just had to add them together. I'll take this away for a second. So remember, this isn't the moment where we're doing FOIL. We're not doing any box method. We're not doing anything multiplying. This is just a subtraction problem. We're adding and subtracting. So it's just like early last week, which is really straightforward. So in this review, remember if it's subtraction, all I have to do is first distribute that negative sign. I drop my parentheses, and I end up with that line of terms. Okay. What's our next step? Combine like terms. So I know I can combine the negative 2x and the x. Get negative x, the positive 3, the positive 4, it's positive 7. That would be the end. So the same thing is going to apply when we have imaginary numbers. Actually, this is a complex number, the real and the imaginary, the real and the imaginary. The only thing we have to remember is we can't combine imaginary and real numbers. Very, very similar to how we can't combine a variable and a number. The same thing applies. We can't combine these. This is as simplified as we can go. Right? So the same thing applies, just as though this was, x plus 2, x plus 1. Because it's addition, there's really nothing to distribute that's going to change anything. So 6 plus 5i plus 8 minus 3i. Nothing changes over here because it's an addition problem. Those signs aren't changing. At this step, I know that I can remember that I need it in this form. I need the real number, real, and I need the imaginary. So that's the imaginary component. That's the real component. So I'm going to first look at my real numbers because those have to go first anyway. What's 6 plus 18? Sorry, 6 plus 8? None of those numbers are right. 14. All right, what's 5i and negative 3i? 5 minus 3? 2. And that would be my answer. Now, if you end up with a combining of like terms that gives you, or it takes away all the I values, I still want you to write it for today. If this ended up canceling out our i's, I want you to write it as 0i. Because that's going to help you just identify, is it wholly real or is it wholly imaginary? The what? Oh. Yeah, let's add 0 so that it matches. Good catch. All right, so they're going to want you just for today to put it in this form. On the test, I don't think that we'll be doing it at that point. Okay, but just keep that in mind. If this was 0 plus 14i, I would still put a 0 just to show that it's still a complex number. It's just imaginary, and this one's real. Because one of the parts is there or it's not there. All right, how about when we have this problem here? We're not really intimidated by that because we just have to distribute this negative first, and then I end up exactly where I was before. 5 plus 6i minus 5 minus 3i. All right, what there can I combine? Let's go for the real number first. So we have a positive 5. We have a negative 5. That gives us 0. Positive 6i and negative 3i. 6 minus 3? Positive, right? Because it was positive 6. Okay. So this would be my answer. Is this complex number wholly real or wholly imaginary? Yeah. It's wholly imaginary. Oh. It's horrible abbreviation. All right. So far, is there anything really new that we've been dealing with here? It's very similar to this, right? Just instead of a variable, we have a term that has an imaginary component to it. or the expression has a imaginary component. Oh yeah. All right, so there is going to be in the homework one additional step with this. So I want to show you this problem, but if you're totally solid with how we did the warm-up, then this next step isn't going to be any issue. Okay. Here are the steps for when it gets this complicated. We're going to start by simplifying the complex number, if possible. So let's take, let's go with 4 plus 3i plus 10 plus, let's just go with I to the 7th. So the reason we have to simplify it is that I to the 7th, we can make that, we can convert that into one of our standard I values. Remember, these always repeat. You get to 5, you start back at the top with the answers. You get to 9, you can start at the top with the same answer. So let's go ahead and first do our steps. And let's deal with this term right here. So go ahead and work on that for, let's go just 30 seconds here. Let's get it. Remainder. So I divide that exponent by 4. My remainder is 3. We're not going for decimals, we're going for the remainder. So we're talking 4th grade. This is 4th grade right here. Remainder 3, so I know that I can rewrite this. I can rewrite this 4 plus 3i. I'm going to do a baby step right here. I don't mind if this isn't in your work. This is just a baby step. We know that I to the 3rd power, which we just figured out is identical to I to the 7th. I to the 3rd power is equal to negative I. So how about I go back in? Because I to the 3rd is equal to negative I, now I can go ahead and put negative I in there. Combine our terms in the next step, after the next step. Okay, so from here on out, it's just what we've been doing for the other example problems. All I did was simplify that I to the 7th first. Let's combine our whole numbers. 14, 3i, and negative I, 2i. What's the hardest part about that? Really, there's only one other thing to do, right? Right there. But that's not challenging because we know our rules with I values and exponents. We can figure out what the equivalent is. Question? No? Comment? Nothing today. All right. How are we feeling about this? Thumbs up, thumbs down, thumbs sideways? Kind of iffy? Okay. So we're kind of between thumbs up and iffy. Probably a little bit more thumbs up, but would it be helpful to do another one of these problems like this? Yeah? Okay. So I'm going to go ahead and do that right over here. All right, how about we go with 4 plus 2i plus 5, let's go minus I to the 30th. Okay, so first off, you look at the I to the 30th. Some of you are going to be able to go, got it. Yeah, exactly. So you can start to see that trick. Okay, it might be helpful to think of this also as it's minus I to the 30th. Those parentheses might help you from a mistake. All right, let's see what we get here. Let's see what we get. I to the 30th first, let's deal with that. We know how to do this. We take 30, we divide it by 4, 7, 8, 2. Remainder is 2. So I know that this I to the 30th is equivalent to I to the second power. Okay, now I'm going to go ahead and take our kind of clues here. I know that I to the second is always equal to -1. So now that I've simplified it, this I to the second can be transformed to 5 minus -1. See, the parentheses help me see that it's minus di, so it's minus now the -1 because it's I to the second. Let's go ahead and go a step further. 4 plus 5, 9 plus 1, 10 plus 2i. All right, so the only difference between this and what we started with was that we had to first deal with this. Well, originally it was I to the 30th. We found its equivalent, I second. I to the second is one of our 4 that we can always depend on. Yes, you have those notes available for the test. Just with those 4 things, I think you'll be pretty good to go with that. Okay. Any other questions? I think that's good for the start.